This slide comes from the ESA, European Space Agency. 10 things you did not know about Mars. This is only one of them. It's point number 6. There is buried liquid water on Mars. There is some evidence about this. So the first thing that we've known about for decades now is this bottom point right here. Water ice is present at the planet's poles. That means there's a polar ice cap at the North Pole and another at the South Pole. There are two kinds of ice at the poles. One is water ice. The other is carbon dioxide ice, what we would call dry ice. These polar caps hold about as much water as the Greenland ice sheet. That's a lot of water ice. If it were to melt, it would bury large portions of Mars under several meters of water. So there's just a tremendous amount of water locked up in these polar caps. They're interesting because they grow during the winter. And recall that Mars is tilted just like the Earth is. So there's northern winter and southern winter, just the way that on this planet we have northern winter and southern winter. What else? So right here is something that's kind of interesting. Radar data revealed a pond of liquid water buried under layers of ice and dust. Radar, it turns out, can penetrate a few meters into the Martian crust, into the Martian soil. If you're interested in this kind of thing, you can read about the skin depth of radar. And that's a way that scientists sort of characterize how deeply radar can penetrate into a surface. But they find surfaces or materials whose reflectivity is very consistent with what we'd expect from dirty ice, right? And so we expect that there's quite a lot of water underground. And if astronauts ever go, or people I should say, ever go to Mars, this is probably where they'll get the majority of their water from. This point right here is something that you may have learned about if you took chemistry. Discovery of hydrated minerals shows liquid water survived for a long time on the planet's surface. It turns out that there are some kinds of minerals or rocks that can hold water molecules in their crystal structure. If you've heard of Epsom salts, these are an excellent example. Technically, Epsom salts are called magnesium hydrate, magnesium sulfate, hexahydrate. But the point is that these molecules of water are trapped in rocks, and sometimes they can make up 20 to 30, even 35% of the weight of a rock, which means if you collect 100 pounds of Epsom salts, if your processing is very efficient, you could pull 30 or 35 pounds of water out of those rocks. That's another good place to look for water on Mars. What else can we say here? This is probably something we'll never have access to. The problem is that they are deep beneath the planet's surface, and we're just not good at digging deep into planets yet. And then this final one, vast volumes of water once flowed across the surface. And in another slide, I'll show you evidence we have for that. The rivers are gone. They've been gone for, in human terms, forever. So for astronauts, these are the two best sources of water on the planet. If we were to go to one of the poles, there's almost an infinite supply of water, at least in human terms, available to us at the poles.